All right, let's do this. This is day one of the 10-day EOC review. Interpret and make decisions, predictions, critical judgments from functional relationships. Keyword relationships. We're looking at different things relating. Several different ways you could relate different things. Main thing that you want to look at is linear, right? But there's also negative linear, quadratic, or what's called no change linear. But basically the two is linear and quadratic. So let me tell you just a little bit real quickly about linear and quadratic. Linear is any relationship that basically looks like this. That makes a line, right? Quadratic is a functional relationship that makes this U-shaped curve, which is called a parabola. Sometimes it also goes like this, though, upside down. That's called a parabola. Also, just let you know on linear, this is a positive relationship, and a negative relationship looks like this. All right, that's negative because it's going down. This is positive because as time goes around, this goes up. This is negative because as it goes on, it goes down. Right? You always look at graphs left to right. There's one other one, and that's called the what they would call a no change. I've never called it that, but a no change linear, which they are referring to a completely horizontal line. That is no change linear because it's just not going up, it's not going down, it's just no change, right? FYI, just more info, this is a positive quadratic, that's a negative quadratic. Think of this as happy, be positive, and think of this as frowny face, it's negative, right? For quadratics. Look at your very first problem. A new battery is placed in a flashlight. The flashlight is left on for several hours. Well, according to this, the y-axis, that's battery life, right? So you're starting off with a full new battery. That means your battery life should be high, at full, at some number high. It could be anywhere around here, really, but as long as it's just up there, it doesn't matter. But then you leave it on, right, for several hours. So that means that as time goes on, since x is time, as time goes on, you lose battery, losing battery, losing battery, losing battery, until you hit this spot right here. Just want to extra note that this is a y-intercept, which describes your start, right? That's what it always describes. This other guy is your x-intercept, which basically is when your y is equal to 0. Basically, when it hits the x-axis, right? This, when you hit the x-axis, that means your y is 0 now. You have 0 battery life, right? That's what your x-intercept is, 0 battery life. What type of relationship is this? Well, this is linear because it's a line, right? Definitely linear because it's a line, and more than that, it's a negative relationship, right? Negative correlation going down. Look at number 2. A baseball is thrown through the air from the outfield to the home plate. I'm going to go ahead and just assume that where our height of the baseball. Let's see here. Well, it could be here or it could stay here, but I'm going to go ahead and start off a little higher than 0. Why am I starting at a height bigger than 0? Because honestly, when you are throwing the ball and the ball in your hand is, you're about 5 feet tall, so the baseball is 5 feet, then you throw it. And when you chunk it, it goes up, your height, right, as the distance goes on. It goes up and up and up and up, right? The farther it goes. But then at a certain distance, it stops at a certain height, and then it goes down and it plummets, right? Not the best looking graph, yeah, I know, and that's where it hits it. This relationship right here is what you call a quadratic. Sorry, my U-shaped curve is not that pretty. It should be nice and pretty, but it's not. FYI, this very top spot is called the vertex because it's the highest point of it. Once again, this is your x-intercept. But also, for those who did not know, an x-intercept goes by 3 other names that it also has. It could also be called the 0, right? It also could be called roots, right? Zeros or roots, or even sometimes it's called solutions. Solutions. But this is a quadratic relationship. A rain gauge is collecting something Asian, I don't know, during a steady long rain shower. Um, hmm, yeah. I honestly have no idea what participation is. I'm gonna go ahead and just guess they mean rain, right? A rain gauge is collecting rain during a steady long rain shower, right? So, level in the rain gauge. Well, to be honest, I'm not exactly sure what a rain gauge is. So I'm not too sure if I'm going to start somewhere or start exactly at zero. But I'm guessing that when they say rain gauge, they're referring to a like a cup, right? A cup outside, and it starts off at zero, and then when it rains, it has water, and you'd be like, oh, it's at level, I don't know, at it rained 3 inches last night or something like that, and you dump it out and you see again. So rain gauge, I'm just going to give you a clue because I want you to work the rest of it. We're going to assume that it starts off at zero. So your very first point I want you to use for your y-intercept is zero, and then I want you to continue it the rest, and then tell me its type of relationship. Look at number 4. Candice discovers a leak while filling a pool. The water flowing from the leak is equal to the water coming from the hose. So, just give you a clue. We have a pool, right? And I'm going to go ahead and assume that there's water in it. They never said it, but I'm just going to go and say we have a pool and there's already water in it. Let's say about like right here, right? There's water already inside it. So that means the water level in the pool, it's like about, I don't know, halfway, something like that. So I'm going to put a point right here. I don't know, halfway. This is just against an assumption. All right, you figure out what happens to the rest. Be careful. This one's really tricky because I just noticed is equal to, right? If the water flowing from the leak, right, is equal to the water coming from the hose, what's going on here? So you got water going in and water coming out. And those two items are equal. What will happen if the water flowing in is equal to the water coming out? I'll let you figure it out. Don't forget also, once you're done, to tell me the relationship. Is it linear, quadratic, etc.? All right, guys, hope this video was helpful and that you learned something and it's helped you with your STAR test. You have a good night.